Inside your body, right now, there is a process running quietly in the background that hunts down damaged and abnormal cells and breaks them apart at the molecular level, almost like a built-in demolition and recycling crew working around the clock. It finds cells that have started behaving strangely, cells with damaged internal machinery, cells accumulating the exact kind of errors that, left unchecked, can eventually spiral into cancer, and it dismantles them, then reuses the raw material to build healthy new cellular components. This process is real, it is measurable, and the scientist who first mapped out how it actually works won the Nobel Prize in Physiology or Medicine for the discovery. It is called autophagy, which literally translates to self-eating, and most people believe the only way to switch it on is through several days of extreme fasting. That belief is incomplete, and by the end of this video, you are going to understand why some of the least obvious ways to activate this process may matter just as much as fasting itself, and how to build several of them into an ordinary week without ever going hungry for days at a time. It is worth sitting with how significant this discovery actually was, because it reshaped how an entire generation of cancer researchers thinks about disease prevention. Before autophagy was well understood at the molecular level, the dominant framework in cancer biology focused almost entirely on avoiding things that damage cells in the first place, things like carcinogens, radiation, and chronic inflammation. Autophagy introduced a genuinely different angle to that conversation. The idea that the body already possesses a sophisticated internal system for finding and correcting cellular damage after it happens, and that system's activity level is not fixed. It responds, moment to moment, to specific biological signals that everyday choices either send or fail to send. That distinction between avoiding damage and actively supporting the body's own repair and cleanup machinery is really what this entire video is built around. Here is what is actually happening inside a cell when autophagy switches on. Every cell contains internal structures that function almost like quality control inspectors, constantly patrolling for damaged proteins, worn-out energy-producing structures called mitochondria, and early signs of abnormal cellular behavior. When autophagy activates, these structures surround the damaged material with a protective membrane, transport it to the cell's internal recycling center, and break it down into raw components the cell can reuse to build healthy new structures in its place. In the context of cancer specifically, this matters enormously, because cancer rarely appears out of nowhere. It develops gradually, through a slow accumulation of small cellular errors that gradually push an otherwise healthy cell toward abnormal, uncontrolled growth. Autophagy is one of the body's primary internal defense systems for catching these early errors and correcting them before they compound into something far more serious. The problem is that autophagy does not run at full capacity all the time. It responds to very specific biological signals, and a great deal of modern daily life quietly suppresses those signals without anyone realizing it is happening. So the real question worth asking is how to send the body those specific signals more consistently, and fasting turns out to be only one of several distinct ways to do it. Modern daily life, it turns out, works against several of these signals almost by design. Constant snacking keeps insulin and mTOR signaling elevated nearly around the clock. Climate-controlled homes and offices remove most natural exposure to meaningful heat or cold, and irregular sleep schedules driven by shift work, late nights, and inconsistent weekends disrupt the circadian rhythm that governs so much of the body's nightly repair activity. None of this happened through any deliberate design against health. It is simply a byproduct of convenience and comfort becoming the default in a way earlier generations never experienced. And understanding that helps explain why deliberately reintroducing these specific signals, through the 5 triggers covered in this video, can matter so much for a body that evolved expecting them to show up regularly. The first trigger, and one that rarely gets discussed outside of specialized research circles, is protein cycling. To understand why this works, it helps to understand a cellular signaling pathway called mTOR, short for mechanistic target of rapamycin. Your cells constantly monitor how much protein is available, and when mTOR detects abundant protein, it suppresses autophagy and sends a growth signal instead, essentially telling the cell to focus on building rather than cleaning house. Cancer cells exploit this exact growth signal more aggressively than most healthy cells, which is part of why overactive mTOR signaling shows up as one of the most frequently altered pathways across a wide range of human cancers studied at the molecular level. When protein availability drops, mTOR shifts the cell into recycling mode instead, activating autophagy to clear out accumulated cellular debris. Research on periodic protein restriction, including work published in the journal Cell Metabolism examining how cycling protein intake affects cellular signaling, has found that reduced protein intake activates autophagy through a pathway distinct from, and complementary to, the one triggered by calorie restriction alone, while independently suppressing mTOR activity. The practical version of this is genuinely simple. 1 day a week, eat noticeably less protein than usual, leaning primarily on vegetables, fruit, and whole grains, with only a small amount of protein included. On the remaining days, eat adequate protein to support healthy muscle maintenance, since ongoing muscle health matters enormously, particularly as people age. The actual anti-cancer signal here is not permanent restriction. It is the deliberate cycling between higher and lower protein intake, which keeps mTOR from settling into a constant, uninterrupted growth signal. This particular approach draws directly from a broader body of research on fasting mimicking dietary patterns, developed specifically to capture some of the cellular benefits associated with fasting, while remaining considerably more sustainable for most people to maintain over the long term than extended water-only fasting. The appeal of protein cycling specifically is that it requires no calorie counting and no extended period without food at all, only a deliberate shift in composition on 1 day of an otherwise normal week, which makes it one of the more realistic entries on this list for anyone who has tried and struggled with more extreme fasting protocols in the past. The second trigger involves something most people have never connected to cancer prevention at all: heat stress. When the body is exposed to significant heat, cells activate a protective response called the heat shock response, and part of that response involves a measurable increase in autophagy, specifically aimed at clearing out the damaged proteins that heat exposure itself produces. The heat shock proteins generated during this process also appear to help direct the immune system's attention toward abnormal cells, since as autophagy clears away heat-damaged debris, IT can expose abnormal markers on the surface of unhealthy cells, making them somewhat easier for immune cells to recognize. A large study published in JAMA Internal Medicine, following men in Finland who used a traditional sauna regularly, found that those using a sauna between 4 and 7 times per week had a significantly lower rate of all-cause mortality compared to those using one only once a week, with researchers noting cardiovascular benefit as the most clearly established driver, and lower cancer mortality proposed as one plausible contributing factor, though it is worth being direct that this particular study was not specifically designed to isolate autophagy as the mechanism behind that reduced cancer risk, and that link remains a genuinely active area of ongoing research rather than settled fact. For anyone wanting to apply this practically, most research in this area has used sauna sessions lasting somewhere between 15 and 20 minutes, at temperatures generally in the range of 150 to 200 degrees Fahrenheit, repeated several times per week. For anyone without regular sauna access, even a hot bath or a sufficiently hot shower held for an extended period appears to trigger a milder version of the same heat shock response, though the research specifically measuring this effect is considerably less extensive than the sauna studies themselves. It is worth being fully transparent about the limits of this particular body of research, since the Finnish sauna studies, while genuinely well conducted and widely cited, were observational rather than randomized controlled trials, meaning they can show a strong association between sauna use and reduced mortality without definitively proving that sauna use itself, rather than some other characteristic shared by frequent sauna users, is the true cause. Researchers studying this area generally view the heat shock and autophagy mechanism as a plausible, biologically grounded explanation worth taking seriously, rather than a definitively settled causal pathway, which is exactly the kind of nuance that tends to get flattened away when this research gets simplified for a headline. Quick pause here, because if the connection between heat exposure and cellular cleanup is new information for you, this is exactly the moment worth sitting with, since it is genuinely one of the more counterintuitive triggers on this entire list. Two more are coming, and the next one connects 2 compounds you have probably eaten this week without knowing what they were actually doing inside your cells. The third trigger is really a combination of 2 related compounds, spermidine and urolithin A. Spermidine occurs naturally in wheat germ, mushrooms, aged cheese, and legumes, and it activates autophagy directly by interfering with an enzyme that normally suppresses this cellular recycling process. In the context of cancer prevention specifically, Spermidine-induced autophagy appears to selectively target cells accumulating abnormal proteins, a hallmark feature of early precancerous cellular changes. A long-term prospective study tracking dietary intake in a general adult population, published examining cardiovascular and overall mortality outcomes, found that higher dietary spermidine intake was independently associated with lower mortality. Dawes and researchers involved in that line of research have proposed autophagy activation as one plausible underlying mechanism, though it is worth noting that mortality broadly and cancer specifically are not identical endpoints, and this remains an area where the human evidence, while genuinely promising, is still developing. The second compound, urolithin A, is not something you eat directly. It is produced inside your gut by specific bacteria after they metabolize natural compounds found in pomegranates, walnuts, and berries. Urolithin A activates a specialized, targeted form of autophagy called mitophagy, which specifically clears out damaged mitochondria, the structures responsible for producing cellular energy. Damaged mitochondria tend to generate excess oxidative stress and abnormal metabolic activity, conditions that precancerous cells are particularly well suited to exploit for their own survival and continued growth, which means clearing out that damaged mitochondrial material removes one of the earliest biological advantages abnormal cells rely on. Good dietary sources supporting both of these compounds and their precursors include wheat germ, mushrooms, soybeans, green peas, pomegranates, walnuts, and raspberries, all reasonably accessible foods rather than anything exotic or expensive. There is something genuinely elegant about how these two compounds complement each other, since they target different complementary aspects of cellular cleanup. Spermidine's effect operates more broadly across general cellular autophagy, while urolithin A's mitophagy effect is specifically targeted at damaged mitochondria, the structures most directly implicated in the kind of metabolic dysfunction researchers have long associated with cancer cell survival, sometimes referred to in cancer biology circles as the Warburg effect, describing how cancer cells often rely on abnormal energy production pathways to fuel their uncontrolled growth. Addressing both the general cellular cleanup and the mitochondria-specific cleanup through diet, rather than relying on either mechanism alone, is part of why this particular entry earns its place as a combined trigger rather than two separate competing recommendations. The fourth trigger works through the opposite temperature extreme from the second entry on this list, cold exposure. Where heat activates the heat shock response, cold exposure works through an entirely different biological pathway. Exposure to cold triggers a surge in norepinephrine, which activates an energy-sensing enzyme called AMPK, and AMPK activation directly suppresses the same mTOR growth pathway discussed earlier, the one that so many cancer cells depend on for continued, uncontrolled growth. Reduced mTOR activity means fewer growth signals circulating for abnormal cells to take advantage of. Beyond this effect on mTOR, cold exposure also appears to mobilize natural killer cells, a category of immune cells that function as the body's primary surveillance system for identifying and eliminating abnormal or cancerous cells. Autophagy and this immune response appear to work together here, since autophagy clearing out cold, stressed cellular debris can expose abnormal markers on unhealthy cells, making them somewhat easier for natural killer cells to recognize and target. The most practical, sustainable way to apply this is not necessarily an elaborate cold plunge routine, though that is certainly one option for anyone genuinely interested. Simply finishing a normal morning shower with 1 to 2 minutes of genuinely cold water appears to be a far more sustainable habit for most people, and some research on cold exposure specifically suggests that consistent daily application, even at a fairly mild intensity, produces more reliable benefit over time than occasional, more extreme cold exposure done inconsistently. Cold exposure also connects to a broader area of research on brown adipose tissue, sometimes called brown fat, a specialized type of fat tissue that becomes more active with regular cold exposure and plays a role in metabolic regulation, distinct from the more familiar white fat tissue most people think of. While the direct link between brown fat activation and cancer prevention specifically remains an earlier stage area of research compared to some of the other triggers discussed here, the broader metabolic benefits associated with regular, moderate cold exposure, including improved insulin sensitivity, tie back into the same overall picture of metabolic health that runs through nearly every entry on this list. The fifth and final trigger is, admittedly, the least glamorous entry on this entire list, and it is genuinely one of the most overlooked: sleep quality. During deep sleep, the body carries out some of its highest levels of autophagy, not just within the brain, but across virtually every tissue in the body. This is also when the immune system performs some of its most thorough inspection for cellular abnormalities, with natural killer cells actively patrolling tissue for cells that have begun dividing in an abnormal, uncontrolled way. This connection between sleep and cancer risk is not speculative or fringe. Circadian rhythm disruption, including irregular sleep schedules, rotating night shift work, and chronic sleep deprivation, has been studied extensively enough that the International Agency for Research on Cancer has classified shift work involving circadian disruption as a probable carcinogen, based on a substantial body of research connecting disrupted sleep patterns to increased rates of several cancer types. In other words, the consistency and quality of your sleep genuinely appears to influence long-term cancer risk, not merely how tired you feel the next day. The most effective, well-supported way to support healthy circadian rhythm is refreshingly unglamorous, maintaining a consistent bedtime and wake time every single day, weekends included, ideally keeping both within roughly a 30 to 45-minute window day to day. This single habit, more than almost any specific supplement or gadget, appears to be one of the most effective ways to stabilize the body's internal biological clock and support the nightly autophagy process running throughout every tissue in the body while you sleep. Beyond consistency and timing, the depth and quality of sleep matters just as much as the schedule surrounding it, since the highest levels of nightly autophagy appear to occur specifically during deep, slow-wave sleep rather than lighter sleep stages. Common disruptors of that deep sleep stage, including alcohol consumed close to bedtime, a bedroom kept too warm, and screen use in the hour before sleep, can reduce time spent in this specific restorative stage, even when total hours of sleep look adequate on paper. Addressing these disruptors directly, rather than focusing only on total sleep duration, tends to produce a more meaningful improvement in the specific sleep stage most closely tied to this nightly cellular cleanup process. Now back to the finding mentioned at the very beginning, the one that genuinely challenges the common assumption that prolonged fasting is the primary, or even the most important way to activate autophagy. To be completely clear, prolonged fasting absolutely does activate autophagy, and for people who find it sustainable, it remains a genuinely effective strategy worth considering, ideally with medical guidance for anyone with an existing health condition. But the current body of research increasingly suggests that the highest levels of everyday baseline autophagy come not from relying on any single method in isolation, but from activating this process through several complementary mechanisms working together throughout an ordinary week. Protein cycling one day, a sauna session or hot bath a few times a week, foods rich in spermidine and the precursors for urolithin A, worked into regular meals, a cold finish to a morning shower, and a genuinely consistent sleep schedule stacked together appear to produce a more reliably elevated baseline of cellular cleanup than any one of these strategies attempted alone. This stacking approach also sidesteps one of the most common reasons extended fasting protocols fail for so many people long-term, which is simple sustainability. A single, extended, multi-day fast requires enormous discipline and is genuinely difficult to fit around work, family, and social obligations on any kind of regular basis, which means many people who start an ambitious fasting protocol abandon it within weeks, receiving no consistent long-term benefit at all. 5 smaller, individually manageable triggers, spread across a normal week, ask for far less from any single day, which in practice tends to produce something that actually sticks around long enough to matter. Researchers studying the broader relationship between lifestyle and cancer risk estimate that somewhere between roughly 30 and 50% of cancers are associated with modifiable lifestyle factors, depending on the specific population and cancer type studied. That is a genuinely significant portion of overall risk sitting within the realm of daily choices, not fixed genetic fate. None of these 5 triggers require a prescription, a specialized clinic, or an expensive intervention. They require consistency and a willingness to build a small handful of them into a week that already exists in some form for most people. The body's own internal cleanup and quality control system has been running since long before modern medicine understood how it worked. And everything covered here is really about giving that system the specific biological signals it has always been designed to respond to, more often and more reliably than most modern daily routines currently allow. It is worth ending on the same note of honesty this entire video has tried to maintain throughout. None of these 5 triggers are a guarantee against cancer, and no legitimate researcher studying autophagy would claim otherwise. Cancer risk involves genetics, environment, and a considerable amount that remains outside anyone's direct control, regardless of how carefully any single person manages their sauna schedule or protein intake. What this research does offer is something genuinely valuable within that larger picture, a set of specific, biologically grounded, low-cost habits that appear to meaningfully support one of the body's own natural defense systems, worth building into an ordinary week not as a guarantee, but as a real, evidence-informed way to stack the odds a little further in your own favor. If this changed how you think about what actually triggers cellular repair, tell me in the comments which of these 5 you are already doing without realizing it had a name, and which one you are adding to your week first. If this gave you something worth acting on, hit subscribe, because there is a lot more research-backed insight like this coming, and you will not want to miss it.